He holds academic appointments at the University of Cal Berkeley in several departments. Has his bachelor's degree from MIT in 1969. Same year I got my bachelor's degree from Michigan State, Hal. Our football team would beat your football team back then. But that's about all probably would beat MIT in, I must say. Is an MA in mathematics, PhD in economics from UC Berkeley, 1973. He's taught at MIT, Stanford, Oxford, Michigan, and other universities around the world. He's a Guggenheim Fellow, member of the Econometric Society, American Academy of Arts and Sciences, co-editor of the American Economic Review from 1987 to 1990, holds several honorary degrees. He's published numerous papers in economic theory, industrial organization, financial economics, econometrics, information economics, author of 2 major economics textbooks which have been translated into 22 languages. He's the co-author of a best-selling book on business strategy called Information Rules, a strategic guide to the network economy. Wrote a monthly column for the New York Times from 2000 to 2007. It gives me great pleasure to introduce Dr. Hal Varian.
Thank you. Thank you very much for that kind introduction. I'm very happy to be here, particularly since it's only about 10 miles from where I live. I didn't have some of the commuting issues that you may have had. I want to start this morning by telling a little story about some duck hunters who went hunting up in northern Michigan. And when they got there, they decided they needed a hunting dog, so they went to the dog rental outlet. And they were all out of dogs. He says, well, I've got one here that just came in. It's a young dog, almost a puppy. We call him Assistant Professor. Now, he only rents for $10 a day, so he's a pretty good deal. So they rented Assistant Professor, went out, and he was a very enthusiastic dog. He ran through the forest and jumped into the water and fetched those ducks. Didn't quite know what he was doing in some cases, but he performed enthusiastically. So the next year when they came back, they said, let's get that Assistant Professor dog again. They said, well, I'm sorry. We renamed him Associate Professor. Now he's $20 a day. So they rented Associate Professor, and he was great. He was not only was he enthusiastic, he was really pretty skillful by this time. He was able to fetch all the ducks. He was able to swim in the cold streams. They threw him a few scraps of food at dinner, and he was happy. So the third year they come back, and I think you could see this coming. They said, well, I'm sorry, we renamed him Professor. Now he's $30 a day. So Professor, well, he was a little less reluctant to jump into that ice-cold water. And he demanded more than a few scraps at dinner time. So the next year they came back, they mulled it over and finally decided, let's do that for old time's sake. Let's get that dog Professor. And they said, well, I'm sorry, you can't have him. Not at any price. Why is that? Well, we renamed him Dean, and now all he does is he sits and begs. So, well, as you can tell from that story, I was once a dean myself, and after 7 years of labor, I got time off for good behavior. And I thought it might be fun to go try something in the real world. But then the real world seemed kind of scary, so I decided to go to Google instead. So that was a great decision because when I went to Google, there were about 400 people. That was in 2002, and I was there to watch it develop from 400 to 20,000 people that we have today. So what I want to talk about is a little bit about the way we do things at Google, and that's for 2 reasons. One, I think it's interesting. There are interesting models there that can be exported to other situations, including the situation that you find yourself in. And even for those aspects of the company that can't really be exported, I think they're interesting from a scientific point of view to understand how organizations can work in the modern age. Now, Google's corporate mission is to manage the world's information and make it universally accessible and useful. So our employees are quite literally information workers. They don't work with steel and glass, they work with information. Or maybe to use a term with a slightly longer pedigree, they're knowledge workers in the sense that Peter Drucker described knowledge workers way back in 1959. These are the computer engineers and the project managers that build the products and tools that allow Google to manage the world's information and, by extension, knowledge. Now, of course, you as deans, you also deal with knowledge workers because the faculty at your universities organize information, create and impart knowledge, and helps us to better understand the art and science of management. And as Peter Drucker observed, those 60 years ago, managing knowledge workers requires a particular approach. But organizations that can do that successfully have a huge competitive advantage. Now, I like to think about this from the historical perspective. In the first decade of the 20th century, industrialists like Henry Ford and Frederick Taylor developed techniques of scientific management, which those days, of course, was primarily focused on manufacturing. The factory system that was pioneered by Ford and by Taylor has been criticized for its emphasis on efficiency at the expense of workers, but the fact remains that it was these innovations that resulted in this tremendous productivity boom that we saw in the 20th century. Economic historian Paul David has a very nice description of how and why we got this productivity boom. As he indicated, back in the beginnings of the 19th century, factories were mostly run on water. There were water wheels. And you had a big shaft down the center of the factory. And then all the tools ran on a belt that was connected to this shaft. You had the drills and the lathes and the saws and everything scattered throughout the factory, but primarily you tended to put all the drills together and all the lathes together and all the saws together, and then the work was carried back and forth from station to station to run the assembly. Now, when electric power came along, the first thing that happened is they replaced the water wheel with a big electric engine. And so the electric engine drove the shaft. And that gave you some productivity gains because when the water spring dried up, you could run the electricity motor, and when the creek froze or the water froze, you could still run the motor, and so you were able to produce more days of the year, but it didn't really change the way production was organized very much. And then as time went on, the electric motor became miniaturized, and so you put an electric motor on each tool, and this gave you the flexibility to move the tools around. But in general, that flexibility wasn't exercised. Why? Because everybody knew you always put the drills together and the lathes together and the saws together. And it really took Henry Ford to get the bright idea of the assembly line that you could rearrange the tools in a way that would accelerate the production process. Instead of clustering them together, you put them in a line and you moved the product down the assembly line and were able to engage in manufacture in a much, much more efficient way. So during this period, in the early part of the 20th century, Ford and the entire management team were down on the factory floor every day tinkering with the assembly line, lowering this, raising that, speeding this up, slowing this down, building a new jig, etc. And of course, that continuous optimization ended up dramatically improving productivity of manufacture. And today, of course, manufacturing is hugely more efficient than it was 100 years ago. Now, just as the miniaturization of the electric motor allowed you to improve the efficiency and the organization of assembly work and the flow of production across the factory floor, the miniaturization of the computer has improved the organization of knowledge work because it's made information deliverable to the worker, to the employee that needs the information at the time and place that they need it. So just as the flow of product was improved by the assembly line and miniaturization of the electric motor, the flow of information to the organization is improved by the availability of the PC. In the 1990s, we saw these significant productivity improvements from computers and local area networks, which allowed the knowledge work to be distributed efficiently in the organization. And now we're seeing the further improvements that are available from the widespread availability of the World Wide Web and the global internet. So if you go back and look at the tenets of modern manufacturing that really emerged from this assembly line mechanical work model, they all have their analog or extension in the knowledge work side. I want to talk a little bit about that. So the 6 principles that we see in modern manufacturing are routinization, modularization, standardization, continuous production, continuous improvement, and miniaturization. So each of these principles translates to knowledge work in I think, a nice way. So I already talked about the miniaturization. The standardization and the modularization, those are integral parts of information technology in general. And nowadays, in many organizations, you see this kind of continuous production because production is worldwide. And in fact, one very important benefit of this kind of miniaturization and the commoditization, I guess, of information technology is the rise of what I call the micro-multinationals. So there are thousands of companies with dozens of small companies with only a dozen or so employees that are scattered around the world. So I've run into friends here in the Bay Area. I say, "What are you doing?" They say, "Oh, I have a company." I say, "How big is your company?" "Well, we've got 2 people in Italy, 3 people in India, 4 people in Boston, and 2 people here in San Francisco." And you can do this kind of micro-multinational because you have access to technologies that only the largest multinational corporations had access to 10 or 15 years ago. So these micro-multinationals can use email, Skype, wikis, chat, Google apps, all these very inexpensive forms of communication that are primarily available at no cost, and they're able to coordinate the production of work, the knowledge work that they engage in real time around the world. So communications technology that was only available to the mega corporations 15 years ago is now available to the smallest garage startup. Now, small companies represent 99.7% of all firms. They create more than half of private non-farm gross domestic product, and they create 60 to 80% of net new jobs. So the fact that information technology can be made available in this very efficient way to these tiny firms, I think has huge implications for the productivity of the economy going forward. Now, routinization, they talked about a minute ago, that's also a very critical force. Edison reportedly said that invention is 1% inspiration and 99% perspiration. Well, at Google, we believe in cyber sweat. So the idea is the people should have the inspiration, and it's the computers that should do the perspiration. If a task could be routinized at all, a computer should be doing it. Continuous improvement, I talked about a minute ago, is not only due to globalization, but there are also other forces at work. So traditionally, continuous production applied to the assembly line model I discussed earlier. Back in the 1910s, Henry Ford and others were tuning the assembly line. They aimed for continuous improvement in the manufacturing process. Every day they wanted to make it better. And if you look at the Japanese method of manufacture that was touted in the U.S. in the 1980s, they were talking about Kaizen, which means continuous improvement. And with web-based production, producing things using information technology, you can do the same thing, only it's much, much easier because you're working with bits, not with steel and glass. So go look at Google. At any one time, Google is running literally hundreds of experiments. So there are hundreds of experiments going on where you're tinkering with the search algorithm or the ad algorithm or the user interface, in some cases in ways that are so subtle they barely register with the conscious mind. You might see that if this interface is a little bit different, but you don't quite know how it's different or why it's different. So each of these experiments is a carefully designed treatment control model, so you can compare the new proposed treatment, the new change in the ad algorithm or the new change in the search algorithm to what you had before. And after a few days, you discover if you've really made an improvement. If you made an improvement, then you roll it into the product, and the product is improving literally on a week-by-week and in some cases a day-by-day basis. In fact, our big problem now, our worry is that someday it might become conscious. But we do have an agreement. The governor of California, Arnold Schwarzenegger, said that he'll step in if this happens. So we hope he keeps his word on that. Now, as for standardization, it goes without saying that information technology is built on standards. So when we wrote information rules, we talked about the huge profits accrue to a company that controlled a proprietary standard due to the network effects and the collective switching costs that these standards conferred. Well, somebody must have been listening, because today it's very, very hard to build a business around a proprietary standard simply because people recognize those threats and they want to defend against the ceding control to a company that built their business model around proprietary standards. And Google, of course, is built on open standards. We use open source software almost exclusively and support its development both financially and by contributing code. Now, why is that? Well, the easy answer is it's free, so if you have to scale to arbitrarily large operations, it's nice to have a free operating system or free code. But the more important consideration is that you don't want to allow a core piece of your business controlled by someone else. And so by using open source software, we're able to run our business the way we would like to do it, rather than being beholden to an outside provider. Okay, well, I've talked a bit about the technology side of knowledge work, and now I want to talk a little bit about the management. So, as Peter Drucker explained many years ago, there's some special care, some special issues involved in managing knowledge work. And I want to talk about some of the principles we use at Google. And again, I'm not necessarily saying that these could be exported to every business, but I think they're worth looking at. So the first one is hire by committee. So every person who interviews at Google talks to at least half a dozen interviews, usually more, drawn from both management and potential colleagues. And everyone's opinion counts in this interview process, making the process more fair and pushing the standards higher. Now, it's true that it takes a lot longer. That's the big gripe about it. But if you hire great people and you involve them intensively in the hiring process, you get more great people. So it's setting up that positive feedback loop way back when the company was founded, and that's ended up having a huge payoff. One kind of subtle side benefit is because people have gone through this extensive interview process, by the time they start to work, they're pretty much trusted to be able to perform at a high level, and so there isn't the kind of testing or trial period that you see in some organizations. Second thing is we cater to their every need. So Peter Drucker also said this. He said the goal is to strip away everything that gets in their way. So we provide a standard package of fringe benefits, but on top of that, we have first-class dining facilities, gyms, laundry rooms, massage rooms, haircuts, car washes, dry cleaning, commuting buses, with internet connectivity on all the commuting buses, just about anything that a hardworking engineer might want. Let's face it, programmers want to program. They don't really want to do their laundry, so we make it easy to do the laundry so they can do what they want to do, which is the programming. Third thing is we pack them in. So almost every project at Google's a team project. The way things get done is with small groups, 5 to 10 people. And the teams have to communicate. And the best way to make communication easy is to put the team members within a few feet of each other. So Google has a cubicle culture, like most of Silicon Valley. You have cubicles with 4 or 5 people. You don't have your private cubicle, as they do at some organizations. Your cubicle is shared with other workers who are working the same project. So when you want to know what does this variable do, or why was the code structured this way, or where do I fetch this piece of data, you turn around to the guy behind you and you ask him. So it's something where the communication flows. You don't have telephone tag. You don't even have email delays. You're able to get the answers to your questions immediately. So when a programmer needs to confer with a colleague, the colleague is right there. Now, of course, there are also many conference rooms where people go to have private conversations or to talk, because you don't want to necessarily disturb your coworkers if it's something that doesn't involve them. But it gives you the best of both worlds, immediate communication, and when necessary, you can have this extensive verbal communication. In fact, I will tell you that even the CEO at Google shared an office for the first several months he was there. In fact, what happened is he was assigned a private office, but one of the engineers next door felt that his office was too crowded, so he picked up his computer and moved it into the CEO's office. And when the CEO came back, he saw this guy sitting in his office. He didn't know quite what to do, but he introduced himself. And he said, I'm Eric Schmidt, the CEO. And the other person gave his name, and he said, I'm the chief lumberjack. The chief lumberjack was actually the person that managed the logs, right? Okay. So what was great about it is he was employee number 7. He'd been there for a long time, and so every time Eric had a question about how something worked or what something was done, his office mate was able to explain how that particular piece of technology worked. So in fact, the CEO sharing an office, at least for this initial period, that really helped him get up to speed very quickly and get a deep knowledge of what was going on in the company from pretty much a direct line to people who managed it. So it was an incredibly effective educational experience, and I think both parties agree to that today. All right, make coordination easy. So because all members of the team are within a few feet of each other, it's very easy to coordinate projects. In addition to this physical proximity, each Googler emails a snippet once a week to his work group describing what it is that he accomplished in the last week. So those snippets are up there on the web, and you can look at what everybody's doing, see what they're happening. It's easier to monitor progress towards completing projects and synchronize the workflow because you can tell what it is that's going on. In addition to the snippets, we also have OKRs, which are objectives and key results that are put together once a quarter, where you list your objectives and key results for the coming quarter, and then at the end of the quarter, you grade those, see how well you did in accomplishing those objectives and key results, and set up the OKRs for the next quarter. So again, all of this is online. All of it can be looked at by your colleagues, your coworkers, your managers, even senior management in the company looks in on these OKRs periodically just to get a feel for how the work is flowing in the organization. Next principle, eat your own dog food. I guess I'm getting back to the Northern Michigan theme here. Google workers use the company tools intensively. And the most obvious tool, of course, is the web, and we've got an internal web page for virtually every project and every task. They're all indexed, they're all available to the project participants on an as-needed basis. And we've developed many, many other organizational tools which are rolled out as products. So you look at Gmail. I don't know how many of you use Gmail, but it's a fantastic email system. And the reason I think it's so good is it was tested extensively internally. So it had to meet the standards of this very, very demanding set of customers, namely the workers, the knowledge workers at Google. And Google Docs, for example, has been fully integrated in the workflow at Google, so you have multi-author documents. Again, in your environment, I know many documents have several authors, and we've got this rather arcane system of sending files back and forth, and you have version control problems, you have tracking problems, you have people who lose them or don't get them submitted on time. Well, of course, a much better model is to have a single copy of the document sitting up there in the cloud, and then people can modify that document in real time. You can track the changes. You can undo anything you don't like. You can add notes to it. So you've got a much more efficient way to produce multi-authored context. It's the same thing whether it's a word processing document, a spreadsheet, or for that matter, a piece of computer code. Encourage creativity. So Google engineers can spend up to 20% of their time on a project of their choice. Now, there's an approval process and a bit of oversight, but basically, we want to allow creative people to be creative. One of our not-so-secret weapons is the ideas mailing list. So there's basically a suggestion box or an ideas mailing list company-wide where people post ideas that range from parking procedures to the next killer application. So the software allows everyone to comment on and rate ideas and provides a way for the best ideas to percolate to the top. Now, people are always a little surprised about this 20% time. They say, well, what can one person working alone accomplish? And the answer is one person working alone can accomplish a huge amount, and oftentimes they'll co-opt a few other members to come into their project, and then they can accomplish truly amazing things. So some of you may have used Google Scholar, which is what we call a vertical search engine. It's searching scholarly material. That was developed by one engineer in his 20% time over a period of about 6 months. And when it came down to the final month before release, he managed to get an intern to come in and help him out to do the final processes to get the release out. So I asked the person, how is it that you were able to develop this incredible product virtually alone? And he said, because I have this extremely powerful infrastructure to draw on. Because the infrastructure was available to each engineer, to each person who wants to use it, without getting prior approval or committee sign-off or anything like that. They could use that infrastructure to develop projects, and then, if the project's successful, they can argue for deployment, and we see, as a result, these fantastic projects like Google Scholar, which are developed by a very small group of people, and yet have very, very powerful results. Strive to reach consensus. So the modern corporate mythology has a unique decision maker as a hero. CEO is kind of elevated to this mythical position. But we adhere to the view that the many are smarter than the few. And at Google, the role of a manager is a person who aggregates viewpoints, not a person who dictates decisions. So building a consensus sometimes takes longer, but it always produces a more committed team and generally better decisions. Next point, data drives decisions. So at Google, almost every decision is based on quantitative analysis. We build these systems to manage information not only for the internet at large, but also the internal information. And we have dozens, actually now hundreds of analysts who plow through the data. They analyze performance metrics, they plot trends, they do experiments. We have roughly 200 statisticians, econometricians, operations resource, technical analyst sorts of people. And we do this, often summarizing this information in online dashboards for every area we work in, so management can get a snapshot of where we are in pretty much every dimension of the corporation. So ultimately, in business, there's two ways to make decisions. You can use hippos or you can use data. Now, what's a hippo? Hippo is a highly paid person's opinion. So the trouble is, with highly paid people, you don't want them to sit around and debate whether the best background for an ad is yellow or blue. You want them to say, here's the experiment we should run. We'll let the data drive the decision, and now we can move on to the next topic of the agenda. And indeed, just a few months ago, we ran a very extensive set of experiments about what the best color is for the ad backgrounds, and it turns out, in case you ever need to know, the answer is yellow. So now, I want to expand a little bit on that data drives decisions because that's really the area that I work in at Google. Several years ago, I had a group of recent MBA graduates from top institutions like yours. They came to me and they said, we want some classes. And I said, what kind of classes do you want? And they said, we want classes in databases and statistics. Now, when I tell this to my colleagues in business schools, they burst into laughter because everybody knows those are the least popular classes in any MBA curriculum. But in this case, it was absolutely clear to these recent graduates that this is what they needed to know. Because if they went to an engineer and tried to get the engineer to go to the database and pull their data, or they had to go find a statistician to tell them how to conduct a t-test, they would never be able to deliver their project on time. Because management demanded use of the data, the analysis of the data, and scientific procedures to analyze that data. So I ended up teaching a little course. We called it Statistics for People Who've Forgotten Statistics. And we got some other people to teach the database course. And now the MBA students are quite happy because they have access to the raw material that they need to help drive the decisions that make the organization move forward. So at Google, if you want to succeed in your job, you have to be able to do these things yourself. So I want to remind you that some of the things that we do at Google can't be exported to other media. I don't think your faculty would necessarily want to share cubicles. Although, I have to tell you, we had a visiting computer scientist from Berkeley, a friend of mine. When he went back to his department at Berkeley, he rounded up some colleagues, and they agreed to tear out a corridor of their building and turn it into cubicle land, rather than use the traditional private office approach. And so they have these cubicles working there with their graduate students, because in general their model is to work on team projects where you have 4 or 5 people involved in each project. And he says it's been a tremendous boost in productivity in the research work that they're doing, and now they're thinking about tearing another corridor. So it may well be that for some kinds of jobs, that is a much better operating environment, particularly jobs like the computer systems development that I was describing at Google. On the other hand, I think that there are many MBAs that you're churning out that are going to be working for companies where data is widely available and data can confer competitive advantage if you are able to analyze it successfully. So my view is that maybe putting a little more emphasis either from a curriculum side or at least from the propaganda side could be helpful in terms of turning out managers who can be successful in this new information-driven culture. So even if the universities can't or won't emulate some of these aspects of Google, I think that they're still very worthy of study, because these are the kinds of environments that many of your graduates will be working in. So let me stop there. I'm going to open the floor up for questions, and thank you very much for your attention.